Hi, we are a team of 3 students, Kofi, Rophence, and Eteri from New York University School of Global Public Health, and we would like to present our project, Understanding the Decline of the Blood Pressure Control among the US population using Multivariate Decomposition Analysis. Hypertension is a modifiable risk factor affecting nearly half of the US adults. There are racial and ethnic disparities in hypertension prevalence, and structural and socioeconomic factors exacerbate these disparities. Blood pressure control is defined as 130/80, and despite effective management and strategies that exist, blood pressure control rates have been declining in the US since 2013. The goal of our project is to identify socioeconomic and demographic factors associated with declining blood pressure control in the US since 2013. We aim to quantify the extent to which these factors affect the decline in blood pressure control.
For our data sources, we use data from the National Health and Nutrition Examination Survey and included adults over 18 years meeting the American College of Cardiology hypertension criteria. We also use the curated datasets and use the available covariates from there, but added additional covariates such as healthcare utilization, health insurance, food security, poverty levels, depression, physical activity, and sleep disorders from the NHANES website. For this analysis, we restricted our survey to 3 cycles from 2013 to 2020. For the data analysis, we did descriptive summaries for the population characteristics using frequencies and percentages, and also used the multivariate logistic regression with the survey wave as the main explanatory variable, and reported adjusted odds ratio and adjusted prevalence ratios with 95% confidence intervals and p-values. For the multivariate decomposition regression analysis, we use this because it separates the overall change into 2 parts. The first part being the characteristic endowment component that assesses the changes in distribution of explanatory variables, and the second part being the coefficient effect component that assesses the changes in relationships between variables and blood pressure control. For the detailed decomposition, we used Yoon's method 2004 to ensure order invariance in nonlinear decompositions. For the implementation, we did this using the MVDCMP package in Stata and used a detailed decomposition logit model using Stata version 18.
The demographic characteristics were comparable across samples across 3 waves. BP control declined from 67% to 63.8% over years. Highest control was observed in young adults, and lowest control was observed in older adults and Black individuals. The characteristics associated with BP control from the logistic model were the following: age, gender, race, comorbidities such as cardiovascular disorders and chronic kidney disease, lifestyle, BMI, and medication use, especially antihypertensive medications. The results from the multivariate decomposition analysis showed that the 15% of the blood pressure control difference is explained by variances in characteristics or endowment, while 82% of the change can be explained by the effects of the characteristics on the change. In the second model, the outcome was quite similar. 15% of the change could be explained by the characteristics, while 4.6% could be explained by how these characteristics affected BP control. The key drivers here were, again, age, gender, race, comorbidities, BMI, medication, and lifestyle.
As a conclusion, we found that addressing decline in BP control requires not only targeting demographic and health factors, but also understanding how the influence of these factors changes across different populations. For the limitations, we only used a complete case analysis and not all features were explored. For future directions, we plan to employ machine learning for future extraction and conduct sensitivity analysis using missing data imputation and subgroup analysis.
Thank you.